Hello everyone, welcome once again to our channel SR PHARMA GYAN. You can also follow our content in Facebook and Instagram also. Today I am going to discuss about an important topic, that is Cannizzaro and cross Cannizzaro reaction, which is basically the reactions of aldehyde and ketones. Let's go to the topic. Before discussing the Cannizzaro and cross Cannizzaro reaction, we need to know something about alpha carbon atom, alpha hydrogens, uh, enolate ion, and disproportionation reaction. The same thing, that is alpha carbon atom and alpha hydrogen atom, that I have discussed in the video of aldol and cross aldol condensation. Let's have a glimpse of this. The carbon atom that is attached with the functional group. This is the functional group here. So this is alpha carbon atom. The second one is beta carbon atom. Okay. Now the hydrogen that is attached with the alpha carbon atom. So this hydrogen is attached with this alpha carbon atom. Then these hydrogens will call this as alpha hydrogen atom. Now for this is a ketonic group. So this carbon is attached with this ketonic group, the functional group. This is alpha carbon atom. This is beta carbon atom. Similarly, this carbon atom is also attached to this carbonyl group. This is also considered as alpha carbon. This is considered as beta. Okay. Now, what is enolate ion or enolates? If you see this example here, is a acetaldehyde in which this is having an alpha hydrogen atom. This is alpha carbon, these are alpha hydrogen. So this alpha hydrogen is transferred from this carbon to this oxygen, and this double bond is shifted between these two carbon atoms. Okay, so the new product that is forming here, it is a OH group. This double bond O is converted to OH group. This is alcoholic group. So that is also called as ketoenol tautomeraism. So this is only possible if alpha hydrogen is present. This actually called as enolate. Similarly, it is also occurs in ketones also. This is aldehyde and this is ketones. So both aldehyde and ketones are showing the formation of enolate. Now what is disproportionation reaction? Actually, disproportionation reaction is a redox reaction in which the reaction between two similar compounds. If you see that this is also formaldehyde, this is also formaldehyde. Between two similar molecules in which one molecule is getting oxidized and another molecule is getting reduced. So this is a aldehyde. Okay. So if aldehyde it get reduced, what it forms? It forms alcohol. Okay. That is CHO. It gives CH2OH. You see that there is a increase of one hydrogen. So addition of hydrogen is a reduction. Okay. So if aldehyde had reduced, it gives alcohol. Similarly, if aldehyde it get oxidized, it gives acid. So this CHO group, it get oxidized, it gives C double bond H. So if you see the number of carbon and hydrogen is same, but there is an increased number of oxygen. That is addition of oxygen. So this is oxidation. So if you see that this is an aldehyde group which is converted to an acid. This is HCOOH. So this is oxidation. And this compound, this is the aldehyde, is giving an alcohol. So that is the reduction. So in the similar reaction, one molecule is getting oxidized, another molecule is getting reduced. So this type of reaction we are calling as disproportionation reaction. Why we are discussing all this? The aldehyde and ketones, if it does not contain alpha hydrogen, then only it will undergo Cannizzaro reaction. So this hydrogen should not be present. Then only these aldehydes and ketones will undergo Cannizzaro reaction. If alpha hydrogen is present in any aldehyde ketone, then it will undergo aldol condensation. Okay, it's clear. Now enolate. You see that if alpha hydrogen is present, then only the enolates are forming. Okay. So enolates. That means the compounds aldehyde or ketones does not forms enolates will undergo Cannizzaro reaction. I'll repeat it again. If it contains alpha hydrogen, aldehyde or ketone contains alpha hydrogen, it will not undergo Cannizzaro, it will undergo aldol. If alpha hydrogen is present, then it forms enolate. No hydrogen, no enolate. So automatically the same thing. Non-enolates will undergo Cannizzaro reaction. Enolates will undergo aldol condensation. And aldol condensation generally is a disproportionation reaction because in aldol condensation, one molecule is getting oxidized to acid, another molecule is getting reduced to alcohol. Okay. Now coming to the Cannizzaro reaction. It's a base-induced disproportionation reaction. So what is actually disproportionation reaction that we have already discussed. Now, non-enolizable aldehydes will give primary alcohol and a carboxylic acid in Cannizzaro reaction. Okay, we have that must be having non-enolizable aldehyde, which will contain no alpha hydrogen. If you see this example, this is an formaldehyde. It does not contain any alpha hydrogen, no alpha hydrogen. It is forming one acid, carboxylic acid, and one. Okay. If you take another example of aromatic aldehydes, here no hydrogen is present. Similarly, no alpha hydrogen. It is giving CH is converting to COOH in oxidation. CH is converted into CH2OH in reduction. Okay. Now, if we take two different type of aldehydes, one is benzaldehyde and one is formaldehyde. What it is forming? This is getting reduced to give alcohol and it oxidized to give an acid. Okay, so this is actually Cannizzaro reaction. Now coming to the mechanism of this reaction. So this mechanism actually three-step process. In the first step, nucleophilic attack of the carbonyl compound. This Cannizzaro reaction is processed by using strong alkali that is like KOH. So this OH having the capability to attack this positive carbon atom. As this is a polar bond, it will get a delta positive charge and delta negative charge. This OH will attack this carbon and partially positively charged carbon. So it is forming this compound, and further this hydrogen is getting abstracted, and this bonded electron will go to oxygen. If you see here, it is a anion. Here it is anion. So there is a formation of two anion in the first step. This is called as dianion. The nucleophilic attack of the carbonyl group to form dianion. Now this dianion is reacts with the fresh molecule of aldehyde. So this hydrogen is removed as hydride ion H minus, and it is attacking the delta positively charged aldehyde. So this is converting to alkoxide. Okay, and this oxygen is shifting again here. This hydrogen is removed with the bonded electrons, so there will be a formation of double bond. So this anion will remain as it is. There will be a formation of double bond, removal of H minus ion, hydride ion, which is attacking to the another molecule of carbonyl compound. Okay, so it is forming a carboxylate and it is forming a alkoxide. The alcoholic group it will form. Now the next step is protonation of alkoxide to an alcohol. Here water molecules, hydrogen is abstracted from here, it will give an alcohol. Similarly, as we are using a basic medium, KOH, here oxygen was abstracted, here KOH will be abstracted, it will be reacting with the carboxylate ion to give a carboxylate, potassium carboxylate. So this is a salt of carboxylic acid. Okay. Now what is cross Cannizzaro reaction? In cross Cannizzaro reactions, what we are going to get? An aldehyde of aromatic origin and aldehyde of aliphatic origin. If it react together in presence of KOH, one will get reduced to alcohol, another will get reduced to acid. Okay, so here we are using two different aldehydes, then it will form a cross aldehyde product. So if you see the mechanism of this reaction, it is same. OH minus ion is reacting with this and it is forming a dianion, as I have discussed before. Similarly, this dianion, from the dianion hydride ion is abstracted and it will attack the second aromatic carbonyl compound. It will give a carboxylate and alkoxide. So the alkoxide will abstract the proton from water. It will form an alcohol, and this carboxylate ion will react with the potassium plus. It is present in the basic media. It will give a salt of carboxylic acid. So this all about Cannizzaro and cross Cannizzaro reaction. Hope you have understood. Kindly follow us, support us by subscribing our channel. Thank you very much for listening. Thank you.